Communication is a vital part of our lives, and let's face it, communication is also a vital part of the systems that we build, because no system is built in total isolation. Everything communicates with some other application out there. Now, when it comes to asynchronous communication, RabbitMQ is one of the most popular libraries out there. However, as it requires a dedicated infrastructure, it might be a little bit discouraging to even get started with it, but worry not, because in this video I'll walk you through everything you need to know to get started with RabbitMQ and .NET applications. Hey there and welcome to the Code Wrinkles channel. RabbitMQ is one of the most popular libraries when it comes to asynchronous communication. It has a lot of advantages. It is lightweight, it can run on different operating systems, it can even run on the server or in the cloud, so it's very lightweight and very flexible. However, RabbitMQ is a universe in itself, and therefore it could be a little bit overwhelming to get started with it. But in this video, I'll walk you through all the steps that you need to know, and most importantly, through all the caveats that you might face when you want to get started with RabbitMQ and your .NET applications. But before we dive into the setup and into the code part, let's understand better what RabbitMQ brings to the table. RabbitMQ is all about asynchronous messaging or asynchronous communication. To better understand this concept, let's imagine this very simple scenario where we have a UI app, could be a real single-page application, then we'll have an API that has an endpoint that's responsible to create a user, to store the user in the database, which is obvious, and then of course also to send a welcome email, because that's what's nice to do when a new user signs up for our application. So the UI app would in this case make a request to create a user to the API, and the API would have a bunch of work to do. Create a user as a model, persist the user in the database, and then also send an email notification. However, if we think about these three, is that email notification sending kind of like doesn't really belong here, because it's just something that could happen in the background. So we just need the data that we have from database and return the answer. So what we have here is asynchronous communication. Now, if we think about this, and we might have a nice idea, what if we can decouple the email sending from everything else, because they don't really belong together. Sending emails could happen in the background. So we can just come back here and remove the response and remove the email sending that's done by the API, and let's introduce a new infrastructure piece, which is the message broker. Now, the message broker, as the name implies, is responsible to handle communication between different parts. In our case, we have the API, which is a publisher, which publishes messages, and we have our email sending service that is a subscriber to that specific message broker. So now when a new request comes in to create a new user, the API, instead of sending an email, it just places a message to the message broker. Hey, we have a new user. And then the message broker is the one that sends that email, or that lets the subscriber know, in this case our email service, that hey, we have a new user and you need to send an email. To summarize, what we had initially is a fully synchronous communication, because when a request came into the application, the API needed to create user as a model, to persist user in the database, and then also wait to send the email, and only then it would generate a response for the client app. So we wanted to optimize this, and we have decoupled the email sending logic from all the other logic, because it kind of like didn't belong to the application logic itself. So therefore, we have introduced this message broker, and we have achieved a fully asynchronous communication. Now that we know exactly what the value of asynchronous communication is, let's go one step further and let's get started with RabbitMQ, and the very first step is of course to install it. Now we have two different options to install RabbitMQ or to get an instance of RabbitMQ. First option would be to use Docker, and the second option would be to use it locally or to install it locally. The easiest way to get RabbitMQ up and running is to use Docker, and that's what I strongly suggest you. To make sure that you have Docker installed, just use the Docker command, and if it lists out the different commands that you have at your disposal, it means that you should be good to go. If not, then please feel free to proceed and install Docker on your operating system. Once we have done this, the only thing that we need to do is actually run this command. Now this command is very simple, but I really want to dive into some topics or to some aspects on it, because if we don't understand them, we might stumble upon a lot of different problems later down the road. So the first thing that we need to do is, okay, we want to Docker run, we want to run a container, and we provide this image, this Docker image that we want to run as a container, and it will simply download it from Docker Hub. Now, the choice of the image that we make here is actually very important, because RabbitMQ is a universe on its own, and it has different functionalities and features. And one of the very important features, especially when we get started with RabbitMQ, is the management dashboard. So it means that you have access to an admin UI where you can take a look on how your RabbitMQ instance is performing, what messages are coming in, what messages are going out, and so on and so forth. And that's very important, so we definitely want to do that. So in this case, we use this image that also supports, or this comes with the management interface also, because by default, even if you install Docker locally, by default it doesn't have this management interface activated, so you need to activate that. So that's why we use this image that does this out of the box. And the next very important thing that we do here is we provide some port configurations like this publish flag. And that's very important, because when you run a Docker container, by default, it doesn't really have anything or any port open to communicate with. And we need a way to communicate from our computer to the Docker container, because I would like to access the management interface of RabbitMQ from my web browser, and our applications that we're creating in .NET to kind of like consume or use RabbitMQ will also run on the computer, not on the Docker host or not on the Docker container. So we need to make sure that we have everything at our disposal. So that's why we have these two flags, and they're very important because we need both of them. Now the first one is 5672. It's the default port that RabbitMQ uses for the AMQP communication, so where actually the messages are sent and received and things similar to that. Now, the reason why we provide it in this format is that, first of all, we need to provide the port that we want to open on the container itself, but then we have to provide the mapping to a corresponding port on our computer so that we are able to kind of like use the communication through that port. So first of all, we add this default port for the regular RabbitMQ communication, but then we also want to access the management interface, and that's why we have this second publishing flag where we kind of like specify this binding 15672 through which the management UI will be available. And that's in a nutshell what this Docker command will do and why we need this type of configurations. But this being said, we can just simply run it, and it will take a few seconds until the image will be downloaded, and then RabbitMQ will be up and running on our computer. So now RabbitMQ should be up and running, and one thing that we see is that it has this RabbitMQ management as a plugin that's activated, and that is what I refer to as the administrative dashboard or the admin UI. And to just have a short overview on what this looks like, it would be something like that. Now, the default username and the default password for RabbitMQ is guest and guest. So if you provide both of them, then you should be able to log in. As you can see here, you get access to all the dashboards. So you see the overview, you see connections, you see different channels, and a lot of different other stuffs, exchanges, queues, all of the RabbitMQ related stuff. You can see it here. So from my point of view, when you are getting started with RabbitMQ, this dashboard, this UI is very important because it gives you a visual representation of what your systems are exactly doing, and that's why I strongly recommend you to run this Docker image that also contains this admin UI. On the other hand, installing RabbitMQ locally is a little bit more cumbersome. Not because it is too complicated, but we have to manually install everything, and then RabbitMQ heavily uses this concept of Windows services that start automatically. So in the end, what you'll end up doing is you would have to manage a bunch of Windows services to make sure that RabbitMQ is not constantly running on your computer. And that's why I always suggest to get started, just use Docker, and it's easier than everything else. Now that we have everything covered, let's move over to the code and see how can we implement in our .NET applications this concept of a publisher and a consumer that communicate via RabbitMQ. Connecting our .NET applications to RabbitMQ is in fact very easy. The most important part is to get RabbitMQ running and to understand exactly those port mappings and how it is supposed to work. When everything is in place, then anything else is really a piece of cake. What we have here is two different applications. We have a minimal API, which is this API project, and this will be our publisher. We have a console application that will be our consumer. What I have done already, I have installed the NuGet package, which you should also need to install. This is this RabbitMQ client. Now, once we have everything here, we can go one step further and then just see how we can publish some messages to RabbitMQ using a minimal API endpoint. And here what happens is very easy. We have this map get for greetings that will allow us to test via Postman, and it's very easy to do. And I want to walk you through exactly what we do here step by step in each line of code to understand exactly what each line does and how it relates to RabbitMQ. So first of all, we need to create an instance of this connection factory. A connection factory is used to provide different information, different configurations for the host so that you can then create a connection to your RabbitMQ instance. And in this case, the only thing that we provide here is the local name or the host name, which will be the local host. Now remember the ports that we have used in or that we have mapped when we ran the docker run command, we have used the default ports. So this is why we don't need to specify the ports here. But if you have custom ports, you would, for instance, come here and say factory.port, and then you would specify exactly the port on which you would like to run your RabbitMQ on. But in this case, since everything runs on default, we just provide here the local host. Then the next thing that we do is, of course, based on the factory and the settings that we have defined in that factory, we need to create a connection. And this will create a connection to RabbitMQ. Then the next thing is, the next concept is we need to create a channel. And for the channel, we just use this create model, which creates the channel itself. Now, here comes the interesting part, because what we want to achieve here is that when we get a request to this endpoint, the only thing that we want to do is we want to have this hello world and send it to our message bus. Now, the only thing is with RabbitMQ, you cannot really send directly .NET objects or strings or regular strings, but what we need to do instead, we need to send bytes array. So this is why we have this hello world and then to array, because we want to transform this to a byte array. And then we have this channel that we have created previously, and then we can say here basic publish. Now, in this basic publish, we need to provide, of course, different type of information. And since this is a getting started video, I will not get in depth into each of these topics, because really, for instance, only if it comes to exchange, we could create at least 10 different videos only to cover different types of exchanges in RabbitMQ. Now, what we want to do here is we provide this empty string, and in that case, RabbitMQ will use the default exchange type, which is a direct exchange. Now then we need to provide a routing key, and this routing key configures a binding and a configuration that defines exactly, okay, what messages goes to exactly what exchange and what queue. And then we need to provide a body, which is of course the string that we have transformed earlier to byte array. And that's it. Really, there's nothing more to how we send a message to RabbitMQ in .NET when we already have everything set up. Now I want to go to the next part of the application, and I would like to go to our consumer, because once we have published this message to RabbitMQ, we want to consume it inside this consumer here. So I will also once again paste some code here and go once again line by line to explain exactly what happens on each of them. Now, the first two lines are actually the same that we had also previously. We need to create a factory. In this case, we have provided the host name directly in this object initializer, and it goes the same thing. We provide localhost because it will use then the default port, and we have mapped our container or our Docker container to those exact ports. That's why it's important to understand that port configuration. And then we create the connection, and then we create the channel. Now, the important thing that we do here is we have on this channel, we have this queue declare. That's a very important part, because this is what actually creates a queue. And a queue is very important because when you send a message, or when a publisher sends a message, that message should arrive at a certain queue. And that's why, for instance, even here, this routing key is used, because this routing key will be used to match to the existing queues. Now, there is one thing that I would like to show you. this channel queue declare. If you look in the RabbitMQ documentation, they will say that you can actually declare those the queues both in the publisher and also in the consumer. And the logic behind that is very straightforward. It's that you don't know exactly which of the two applications in this case will start the first one. And if the consumer doesn't start and it doesn't declare the queue, then we wouldn't be able to send a message. We will receive some error messages. However, the problem is that I have found out is that if you already started, for instance, the queue declare here and the queue was declared, then if you run a request to this greetings endpoint, when we arrive at this line of code, it will actually throw an error that it couldn't acquire a lock. And that's why for our demo purpose here, I would just suggest you to comment out this line of code. Now let's go back here to our consumer, because then here after this queue declared, the only thing that we need to do is we need to provide a consumer. Now the consumer is the instance or the object that will consume the messages that will eventually come to this consumer from that specific queue that is called greetings. And to do this, we need to create an instance of this eventing basic consumer. And for this one, we need to provide the channel in the constructor. And now once we have this consumer, we can then just simply have this callback method that will trigger each time that we receive a new message, or every time that a new message is received on the queue and it is distributed to this consumer that we have created right now. So it means that that's actually the logic where we get the message from the queue and we can do whatever we need to do with that. Now, of course, as we know that the body that we have in the event, like the message itself, is a byte array, what we want to do is, of course, we want to extract the message from there. And from the message, we want to get the string. So we use encoding UTF-8 get string, and here that's a byte array, and from this byte array, we just get the string back. And then the only thing that we do here is we write this to the console. Now, in a real application, you would kind of like map this maybe to one of your .NET objects, like a Poco objects, and you can, I don't know, write things in the database, do whatever you need to do when this type of message is received. And then on this channel, we just have this basic consume in which we provide exactly the information about, okay, what we want to consume. And we see that we want to consume only things that come from this greetings queue, which is the most important part. And we have this auto acknowledge set to true, and then we have to specify the consumer that we have just created. And that's it. That's everything that we need to do to have everything wired up together. Now let's go one step further and prove that everything works. And as said, let's start first this one, because this is the project in which we actually declare the queue. And then once this is started, let's also move over to the API and also let's start the API. And of course, right now we have just started the API, so we haven't really published anything. So let's just wait a few seconds that the API is also up and running. And I would like to go here to this consumer part, because here is where I would like to see the output of this console write line message. And yeah, maybe let's just put a breakpoint here. Let's maybe also go to the API and yeah, put just a breakpoint here to prove how everything is supposed to work. Now, of course, it seems that it doesn't really, or it's not able to really work. Let's maybe try here a breakpoint. Okay, cool. Now let's go over to Postman and send a request to these greetings. So we have sent the request and we see that we have hit this breakpoint. So we create the factory, we create the host name, and so on and so forth. And then we just publish the message. Let me go just forward. And we see that right now we have jumped here to this breakpoint that we have in our consumer. Like this is the consumer program.cs. So that's where our consumer is. So we get this body as an array, and then from the body, we want to extract the message. And the message, guess what? It's hello world, exactly what it has been on our publisher. And obviously, when we put this on the consumer, we'll have this, or when we put this in the console, we see this message in the console. So you see that we were able right now to communicate some information from the API project to the consumer project without those two projects actually being referenced one by the other. So everything is decoupled and the communication only goes through RabbitMQ. RabbitMQ and asynchronous messaging in general solves a lot of problems that we might face in our applications because it allows us to easily decouple different components of our systems. However, on the other hand, it also adds specific complexity, because having something like a message broker means that we have to think also in terms of fault tolerance. So what happens if a certain message is not published or if it is not processed in time? We have to think about sequencing, like RabbitMQ and message brokers guarantee us that a message will be processed, but it doesn't guarantee us when exactly that will happen. And this could turn out to be a problem in certain circumstances in our applications. So in that case, we would need to build additional logic in our application to overcome this type of challenges. That's why before deciding that you want to use RabbitMQ, make sure that the benefits outweigh the challenges that such or this additional layer of complexity brings to your application. If you enjoyed this video, please make sure to hit the thumbs up button and like this video. This will make it easier to discover for other YouTube users that might find it useful as well. Also, if you didn't subscribe to the channel, please subscribe and also hit the notification bell so that you are always notified whenever something new happens in this channel. Also, if you have any question or if you just want to get a discussion started, don't be shy and head over to the comment section of this video and just post your question, just write something and I will be more than happy to get in touch with you. This being said, thank you very much for watching, and until the next time, I wish you the very best.